Okay, geometry folks, this is 6.2 geometric mean. Again, 6.2 geometric mean. So by the end of today, you should be able to use geometric means to solve parts of a right triangle and find the altitude to its hypotenuse. And I'll explain what all those pieces mean here in a second. But first off, geometric mean. You've heard mean before, and kind of here's where mean comes into play. Whenever you've got two things that are comparing to each other, a proportion, and you're comparing two equal things, when the means of a proportion, that's this one and this one, are the same number, the number is called the mean of the extremes. Okay, the extremes are these two. All right, so this one's an extreme, this one's an extreme. These would be considered the means. Now, when the means are the same, they call that the geometric mean. Okay, so the mean, remember from stats days, means the average, but in here for geometric mean, it's just going to be when the same number is used twice. So same number, that's not a hashtag, that's a number symbol. So if it's the same number used twice, that's what you're talking about. So if I say find the geometric mean between 8 and 10, so a way to think about it would be this and this. So kind of what you're looking at is x squared equals 8 times 10. So x squared equals 80. So x is going to be equal to the square root of 80. So the geometric mean between 8 and 10 would be the square root of 80, which is going to be really, really close to 9, but still going to be a decimal. I would actually prefer, my best would be is if you would simplify square root of 80, which can be broken down into 16 and 5, which simplified would be 4 square root of 5. So that would be an awesome answer. If you gave me the square root of 80 as 8.944, that would be acceptable. So here, for number 2, find the geometric mean between 9 and 4. So it'd be like 9 over x equals x over 4. So x squared equals 36 because that's what 9 times 4 is. So x is going to equal 6. So my mean here is just going to be 6. Okay. So now an altitude. An altitude is a segment drawn from the vertex of a triangle perpendicular to the line opposite. So vertex just means corner of a triangle perpendicular to the line opposite. So every triangle technically has got 3 altitudes. Okay. So let's start off simple here. I'm going to start with this corner right here. So if I draw the altitude is just straight down, it's got to be perpendicular, which means I make a right angle. Now, this one coming from this corner here, this bottom right corner, going back, the altitude might not necessarily go here. Okay? In fact, this looks like it could be pretty right. So this one might actually be the altitude. So, but let's say that's not. So this might be the altitude right here, and that could be the right angle. And then for this far corner here, maybe this might be the altitude right here. All right, so everything's got 3 altitudes. Every triangle's got 3 altitudes. So using the geometric mean with right triangles. So in right triangles, very, very specific, only works in right triangles. No other triangles is this true. So if the altitude is drawn to the hypotenuse of a right triangle, then the 2 triangles formed are similar to each other and the original triangle. Okay, so let's back up and think about this. So I draw the altitude of a right triangle to the hypotenuse. So I draw the triangle from here straight down to the hypotenuse. So here's kind of what this is saying. This is saying this triangle is similar to this triangle is similar to the big triangle. All right, all 3 of those pieces are similar to each other. So if we create C, we'll call this D. So you've got 3 triangles. So we'll call CD, segment CD, the altitude hypotenuse AB. then you've got three similar triangles going on here. Okay, so I've got ADC, which is this little one right here, and that is going to be similar to DCB. Now remember, you still have got to be careful here with the placement because you're still corresponding here. So I can also say ADC. Okay, so ADC is also going to be similar to the big one. So if it goes ADC, this one's actually going to go ACB. Then the last one, DCB, this triangle here is going to be similar to CAB. Let me double check. DCB is going to be similar to CAB. Yes. So those three situations happen. Whenever you draw an altitude, you create two new triangles. Those two triangles are similar to each other and to the original triangle. So I know it's kind of a lot to take on here. So let's take a look. So if I draw the altitude, I'll call that guy D. It's perpendicular. So if CD is the altitude to hypotenuse AB of right, the length of this altitude is a geometric mean between the lengths of these two segments. So CD, whatever this length is, let's call this one X, and we'll call AD here, we'll call this one Y, and BD here, we'll call this one Z. Okay, this whole thing, by the way, is still the hypotenuse C. So kind of what this is saying is the length of the altitude is the geometric mean between the lengths of the two segments he cuts up. So if I say Y over X is going to be equal to X over Z. All right, so this times this, Y times Z equals X squared. That's what they're saying. Y times Z equals X squared. So figure out the values of X, Y, and Z. Okay, so we know we're assuming that MLZ altitude, okay, it says it's perpendicular, we're going to go with that. So here's where I'm going to start. Okay, I'm going to use two things. I'm going to use geometric mean stuff, and I'm going to use Pythagorean theorem because these are still right triangles. So here's what I just know. I know that 20 and 5 get split up here by X. So this whole thing together is 25, but I don't care about that right now. But what I do know is this. 5 over X has got to be equal to X over 20. That's just what I just said. Altitude is a geometric mean between the two pieces that it cuts up. So X squared equals 5 times 20. 5 times 20 is 100. So X is going to be equal to 10. Okay, so this guy's 10. Fine. Now it becomes a matter of using Pythagorean theorem twice. All right, for this triangle down here in red, it's a right triangle where this is 5, this is 10. We got to figure out how big y is. So I go 5 squared plus 10 squared equals y squared. So that's going to be 125. Square root of 125 is going to be just over 11. So it's 11.18. So then for Z, for this top one, I want to do the same thing. All right, for not this guy, except here's what here's kind of what it's going to look like. So this is going to be 20, 10, and this is Z. So it's going to be 10 squared plus 20 squared equals Z squared. So that's 100. That's 400. So 500 equals Z squared. So square root of 500 is going to be actually 10 square root of 5 as a simplified fraction, but it's going to be 22.36. So there's my answer. There's X, there's Y, there's Z. X is 10, Y is 11.18, Z is 22.36. So here, find the values of C, D, and E. Well, I think they mean X, Y, and Z, so go with that. X, Y, and Z. So I'm going to do the same thing again here. Well, actually, you know what? I'm going to go in a different order. I can figure out right here what z is because I got a right triangle here. So that's going to be 9 squared plus 12 squared equals z squared. So it's 81 plus 144 equals z squared. 81 and 144 are 225. 225, the square root of that is going to be 15. So there's my answer there. Now to figure out x and y, here's what I got to do. Well, first thing I'm going to do is figure out x. So remember, x over 12 has got to be equal to 12 over 9. So 9x equals 12 squared. So 9x equals 144. So 144 divided by 9 to solve that is going to be 16. So that makes this 16. So then final piece, figure out y here, is going to be take 16 squared plus 12 squared, and that's got to give me y squared. So 16 squared is 256 plus 144, because that's what 12 squared is. So y squared equals 400. So y is going to equal 20. So this guy is going to be 20 right here. Okay, so let's figure out the value of w. So a little bit tougher one here. You've got w plus 4, and then 24 plus and 6. So here's where life gets a little complicated. Here's where algebra stuff has to come back. So this and this equal this squared. So 24 times 6 equals w plus 4 squared. Now, knock off the algebra rust, okay? 24 times 6 is 144. W plus 4 is not w squared plus 16. That's not it. W plus 4 squared is going to be w squared plus 8w plus 16. I know I'm going to get somebody with that. I know it. I know it. I know it. I know it. So I'm going to subtract 144, subtract 144. So it equals 0. So I get w squared plus 8w minus, what's 144 minus 16? 128. Now I have to factor. Aha. Words that strike fear into all math students' hearts. Factoring. So this is where I work backwards. What multiplies to 128 subtracts to 8. Okay, you can draw your x, negative 128 and 8, and figure that out. So start playing around with factors. So 128 and 1, 2 and 64, 4 and 32. So I got to figure out what subtracts to 8. So let's go again. So let's see, that would be 8 and 16. Hey, there's a winner. So I'm going to go positive 16, negative 8. So factors are going to be w plus 16 and w minus 8. Still equals 0. So remember, set each part equal to 0. So w either has to equal negative 16 or w has to equal 8. Well, if I go negative 16 plus 4 is negative 12. I can't do that. Negative 16 plus 4 equals negative 12. I can't have a negative distance. That doesn't work. So it's just going to be the positive one. So w is going to be 8. That's going to be the winner. All right, that's all I got. Please come see me with questions, and we'll talk to you very, very soon.